hello students, welcome back to our video classes. And today we are going to start with the methods of separations of constituents of mixture. Okay. And I am Anik Ghosh with you, your chemistry teacher. And I think you have seen all the previous videos. Okay. I think you have understood them. Okay. And if you have any doubt, you can write it on the forum, right? You know it already. So the things are, before starting this video, I would like to strongly suggest you to go through the previous videos first, because today we are going to separate out the constituents of mixture. But before doing that, you need to know how many types of mixtures are there, isn't it? And apart from that, what are the like how to make a mixture, what are the constituents needed to make a mixture, and only then you'd be able to understand how to separate out these constituents, isn't it? So there are so many different ways, mainly the physical methods today we are going to learn, like decantation, sedimentation, filtration, centrifugation, evaporation, and sublimation. Okay, so these are the methods we are going to learn today. And along with that, as we generally do, we are going to see some cool videos as well. Okay, so just give me a moment. Fine. So as you can see, like we are here, and first thing we are going to learn today. So the thing is, why do we need this separation of mixture on the first place? So if I just try to think about that. So first thing, the question that comes in your mind, why? Why do we need to separate the mixtures? So first of all, the main reason is to make it pure, isn't it? So all the things that comes in our daily use, for our daily use in our house, all of them are not pure, and we want to make them pure. So for that reason, we need to know how to make them. So if there are some impurities in a particular thing that we are bringing up, okay, then we need to know how to separate these impurities. So for that reason, we need to know how to separate out the mixtures, right? Apart from that, what else? So think about it, like if you have, so this thing is clear, I guess. Right. Apart from that, what else, in what cases you need to separate out the mixtures? So you try to think about it. There are so many reasons behind it, right? The second thing is, like, think about it, like you are trying to eat rice, okay, and if you're in the inside your rice, there are stones, you'd not be able to eat them, right? So you need to separate out the stones from the rice, isn't it? If you are trying to make us medicine or something like that, you need to wash the impurities, you need to separate out the impurities first to make that thing. Okay, if you want to if you are trying to take out some metals out of its ores, there also you need to separate, you need to use some of these methods only to separate out them. Okay, so apart from that, in metallurgy, right, so where we are going to learn about in stream, where we generally discuss about the extractions of metals from the ores, from its ores. Okay, got it. Now the thing is, you can see, like, these are the processes that we have already gone through them. Give me a moment. Yeah, so the first thing through which what is sedimentation? Separate out the solution mixture where one is heavier than the other. So just think about it. If you are taking some water, okay, and if this water is muddy, then what would happen? Definitely, just give me a moment. It's wrong, I guess. Yeah, we are here. So the thing is, back again. So the thing is, if this water is a little bit muddy water, then what would happen? So as the mud particles are heavier, at the mud particles are heavier, the mass of mud particles are very high, so they are not prone towards floating in the water. So what would happen is they would try to get down due to the gravitational force of attraction, isn't it? So for that reason only, what would happen, they would try to go down. And if you just keep this solution for a moment, not a solution, this is just a mixture, if you just keep that thing for a moment, or like or a minute or two, 1 to 2 minutes, then what would happen, all the mud particles would get settled down below, isn't it? So this thing over here, now when you are having this type of solution, when all the things are getting precipitated, or I should rather say sedimented, all the particles, those are, they're in the bottom, that is called the sedimented particles. So when they have got sedimented, after that what happens is, you can see the rest of the solution, that would look like this, isn't it? Entire solution would be, the entire solvent would be at the top of the solution. What would happen is, if you just take out the water, then what would happen? Think about it. You have a beaker, okay, full of muddy water. You are keeping that for a moment, 1 or 2 minutes. All the muds are getting sedimented down because of the gravitational attraction forces, because the mud particles are bigger, because that for that reason only it is having greater pull towards the center of the earth, right? Due to the gravity only. Now after they get settled down, okay, the entire solution, the entire water is there on the top of it, and the mud is there in the bottom of it, of the beaker. I'm trying to tell you, the beaker, and at the top of it the entire water is there, right? Now what would you do to separate out this water and this mud? What would you do? You would just take out this water slowly to another beaker, isn't it? That is what is happening over here. If you just take out the rest of the solution in another beaker, so in the end you would get all the muds in one beaker and entire solution in the other beaker, isn't it? So the solution which is there, this solution where all the mud has been sedimented down below, and the rest of the solution is called a supernated liquid. We call it supernated, supernated liquid. Fine. And when we just take out the entire solution to another beaker, we call this process decantation. Okay, decantation. So I'm just trying to tell you everything all over again to make it, easier for you. So in the sedimentation process, heavier components of the mixture settles down at the bottom due to gravity. So what is happening over here? The thing is, you can see this picture. In this picture, the solution is the blue one. So the water is the blue one, and all the red ones are the muddy mud particles. Okay. So when you just keep that thing, when just you just keep that thing for a moment, what would happen? That all the muds over here, you can see, so all the muds are there at the bottom of it, right? And the rest of the solution, the clear solution, is on the top of it. We call it the sediments. So all the things, those are getting there in the bottom of the beaker, we call it sediments, right? That's why we call the process sedimentation. We call it sediments. And the rest of the solution, this thing is called supernated liquid. Fine. Supernated liquid. Got it? Now, after that, what would happen if you just take out this supernated liquid? You know how that you can see how they are just taking out the supernated liquid to another beaker. This process is called decantation. You can see over here the decantation process involves pouring clear upper liquid of the container without disturbing the sediment. So because if you just disturb the sediment again, then what would happen? That would get solubilized again, right? So you need to pour this solution in such a way very slowly. You need to pour this solution very slowly in such a way that these sediments won't get disturbed anyway. Okay, so they shouldn't get disturbed. Got my point? And you need to just pour the entire solution very slowly. You can see they're using a glass rod as well. They're using this thing is called a glass rod. Okay, they're using a glass rod okay, they take out the solution because in the with the help of that glass rod they would be able to take out the water easily. Okay, so that was the first process. So this decantation and the sedimentation, we use this process to separate out the solutions where one of the particles is heavier than the other one. Fine. Now moving on to the next part. You got it? Now let's discuss about the next part, which is called filtration. Fine. So now filtration. Now what is filtration? I think this is the most common method that we use in our everyday life. So I think you know about filtration. So what is happening in filtration? So when you are separating the tea leaves, okay, from your tea, so what do? You just take a sieve plate, isn't it? You just take a sieve plate like this. It looks like something like this. Okay, I'm not very good at drawing. I think you know that, right? Now after that, what you do is you just pour your entire tea from here. And what happens is after that what happens is the entire tea goes through it. There are very small pores in it, isn't it? There are very small pores in it. So as a result, what happens is the entire tea goes through it in your glass, okay, or tumbler from where you are trying to drink it, something like this. Okay, the entire tea is falling into your glass. Now, after that, what would happen is the rest of the tea leaves. So this is your blue tea. I think you haven't heard of blue tea earlier, right? So this is your blue tea, and what would happen is the rest of the tea leaves would get they won't be able to pass through the small pores, isn't it? Small pores. So the tea leaves would be there as a residue. They would be there in the sieve. This is a sieve plate. Sieve plate. So the entire thing would be they're stuck there and the solution would go through it. So in this process as well, we can separate out a mixture when one particle is smaller and the other one is very big. So one is very big, another one is very small. Only then we can separate out that thing with the help of this process. So you can see filtration is the process of separating suspended solid matter from a liquid. Suspended solid matter. Okay, by causing the latter to pass through pores of some substance called a filter. Okay, and the liquid which has to pass through the filter is called the filtrate. Okay, they have some names as well. So as I told you, while we are dealing with the tea, and there when you just taking out the tea, after that when you are taking out the tea, it is there in your glass, which goes through the sieve plate, which goes through the filter. Okay, that is called the filtrate. That is called the filtrate. And the tea leaves over there, they are called the residues. They are there called the residue. They are there in the sieve plate only. Okay, they are there in the filter only. We call them residues. Now let's watch this small video to understand this process in details. This is about decantation first. You can see how they are separating this thing in that decantation process. You can see the supernated liquid is just being poured in another beaker, right? Yeah. So you can see, if you just try to do the decantation process for tea leaves again, you would be able to see that the process is not a very good having a very good prospect, right? So if you try to decant tea, the tea leaves are not heavy enough. So for that reason, you would be able to see that in your decanted tea, there as well there would be tea leaves there, right? Just try to make this a little bit bigger. I think that way it would be easier for you to see, isn't it? Just wait for a moment. Let me see. Okay, so this is embedded already. I think I won't be able to make it bigger. So you don't worry about it. I think you would have the entire notes with you, right? So you'd be able to see it. Right now, you just try to, zoom in. You'd be able to see everything. So that is a common sense that you won't be able to separate out the tea leaves from the tea, isn't it? So we can just go through it and we can just try to understand the next processes that they are trying to tell you. So actually what happens is the decantation process is not enough, right? So for that reason, you need to take that filter over there. You can see that is a sieve plate. So and the entire tea leaves, the tea is there as a filtrate, and the tea leaves are there on the strainer. So you can also say that that is a strainer. Don't worry about that. And all the tea leaves are there as a residue, like I told you earlier, isn't it? This process is called filtration. Fine. So for tea process, we are using strainer. But for if you just try to think about the water purifier, there we are generally call them filters, isn't it? Now they are trying to do the same filtration method for the water and the mud mixture. Okay, so in that mixture as well, if you just forget about decantation, forget about that. I think you are understanding. If you are trying to separate out two things, if you are trying to discuss, if you are just trying to do the filtration process, there is a problem. Not with the filtration process. If you're trying to do with the decantation process, there is a problem. It would take your quite a few minutes from your valuable time, isn't it? So we can skip that. So we would just, if you have that beaker, okay, with the muddy waters is in it, and with the muddy waters in it. So what you can do is you can just directly filter it. Think about it. The muds are very big particles, isn't it? So if you just filter it with the help of any, take a filter paper or take any sieve plate, something like that, or you can take a like cloth as well. Okay, you just have to take something that has very small pores in it. So what would happen? The entire filtrate would be there in the beaker, right? and all the muds would be there as residues. Got my point? You see, so all the particles would not be able to pass through it, isn't it? So this is something like, you can take this as a strainer, or this is a filter, something like that. Fine. Now what would happen? The entire filtrate, this thing would be the pure water. So as I told you, to purify something, we use this processes, right? So you can see that the filtrate is water, basically, which is in pure form, and all the impurities is there as residue. Okay, fine. So this is the process which is called the filtration. So you can use decantation, but filtration is the further modified process, modified approach, you can say as well. Okay, so these are very simple things, isn't it? Now coming to the next process, which is called centrifugation. Now what is a centrifugation? So to understand that, we are going to see a video, and this video is very cool and very funny as well. So just watch this. So they are saying, the first thing they are saying about this centrifugation processes, they are trying to tell you that this principle of centrifugation is very useful even in the blood banks. So in the blood banks, this centrifugation process is being used. But how? Okay, and what is the centrifugation? Let us see. They're not saying anything. Okay, you can just find it in the YouTube as well. Now, this is a jelly, right? Jelly is a colloidal solution, right? You know about it already. And they're trying to tell you what is a colloidal solution. So the colloidal solution, we have discussed about it in the last video, right? So the colloidal solution is a type of solution where the particle size is 10 to the power minus 6 meter. We can also say a micrometer, right? Up to 10 to the power minus 6. So the particle size is in such a way that it won't be floating in the solution. It won't be getting dissolved completely in the solution, or it won't be something like that, like it would get sedimented in the solution. Okay, it would be there floating inside the solution, and you'd be able to see, like, not be able to see the particles properly, but you would be able to see that it is a translucent type of mixture, isn't it? Like I told you, like milk in water is just an example of that, isn't it? Now let's see, jelly is also an example of this colloidal solutions. Blood is a colloidal solution. I think you know about it, because all the components of bloods, right? You can see the blood cell, the red blood cell, the white blood cell, the platelets, the plasmas, all are there inside the blood, isn't it? So as you can see, the blood contains all of that. So all of them are just like the colloids in a solution. So in blood, we can see all these particles, all these corpuscles, all of them are making the overall mixture as a colloidal mixture. Okay, and they do not settle down, isn't it? Like the colloidal solution generally do. Okay, so you can see, like I told you, when you are there going to a blood bank, okay, just forget about it. When you are trying to do your own blood test, what is the thing that you do? So not you just give your blood, right? So what is the thing that the scientists or the doctors generally do? So in there, they just try to separate out all the components from the blood. They try to separate out the RBC, they try to separate out the WBC, platelets, and all the plasmas, everything out. And from there, what they do is they just give you the count of that, right? That is what they do in your report, right? In your report, you would be able to see the RBC amount, the WBC amount, the platelets amount, all of them, isn't it? So that is what they generally do. Now, Now, how can we separate them? Okay, that is called the centrifugation method. They have started again. No, you cannot do that. You cannot use filter paper to separate out the various components of blood, because the in the colloidal solution what happens is the particle size is not that small. So what happens is you use filter paper. You just try to understand this. Where would we be able to use this filtration process? So in filtration, we would be only be able to use it if the particle size is greater than 10 to the power minus 6. So mainly for suspension. Okay, so in the particle size, this should be the particle size. Only then we can use this method, filtration. But when the particle size is less than 10 to the power minus 6, you won't be able to use that, because the thing is the filter papers, the pores in the filter papers, or the whatever you use, the sieve plate or whatever you use, the pores are not, pores would not be able to, if they are not that much small that they would be able to separate out a particle of 10 to the power minus 4 meter. Okay, they won't be able to do that. Okay, so 10 to the minus 7 or 8 meter, my mistake, 10 to the minus 7 or 8 meter. So they won't be able to do that because they are not that much small. So filter paper aren't going to, isn't going to separate them out. So we need another method when the particle size is even less than 10 to the power minus 6. Okay, so let's see what is the method then. That is the point. All of the components would get passed through the filter paper. So, like the way this merry-go-round, you have seen the way the merry-go-round was spinning, in the same way the centrifugation force occurs. Now, let me just show you something. So, let me show you something. So, this is a thing you can see, and this is a thread over here. Okay. See, if I try to just spin this thing, what would happen? So this is, spinning over here, and the thing, if you just think about the physics, so you can see what are the forces applied over here. So let me show you the things. When it is just spinning like that, so the forces those are getting applied over here is an outward pull. Okay, the outward pull, and the another force which is getting applied over here is an inward pull. What I mean to say is, yes, I'm just trying to tell you about the centripetal and the centrifugal force, isn't it? So we call them centripetal and centrifugal force. And from there only this centrifugation method is coming. I think you got that, right? So the thing is that when you're trying to spin something, there is a force that is acting. Another force which is not letting this particle, not letting this particle, go out of the system, that is just dragging that particle over here. So if you again just try to think about this rope, when it is spinning like that, this rope is trying to pull it towards itself, right, towards the center. For that reason, it is not being able to go out. But when this thing is spinning, there is another force which is acting, that is trying to make it go away. Okay, try to throw it away. So these two forces are getting applied over here, and they are equal and opposite. That's why that is there in this particular position, isn't it? So this is centrifugal force. Another force is acting inward, that is called centripetal force. Centripetal force. Centripetal force is the force that is acting inwards, and centrifugal force is the force that is going outwards. So that is the point over here. So when you are trying to spin an object, the centrifugal force is getting applied over there. Now, what is the work of that force in this separation method? Let's see that. That is the thing what happens in a centrifugation machine. So like this thing, they are just trying to take the blood sample and trying to put it in the machine. So it's just like that. So they just take this test tube, okay, and they just put the blood sample inside the test tube. So this is the blood sample, and what they do is they just rotate the entire thing with a high velocity, like this. You can see high speed, constant high speed. Okay, if they rotate that thing, then what would happen? Let's try to find that. If they start rotating it with a very high velocity, what would happen? So what are the components there in the blood? So there are RBC, red blood corpuscles. There are WBC, West Bengal Corporation, so white blood corpuscles. After that, there are platelets, and there are serum, like serum. We can also say that serum, or would be better. Plasma. Then what would happen? If you just start rotating it, all the particles like RBC, WBC, platelets, and plasmas, all of them would feel the centrifugal force, isn't it? When the entire test tube is rotating, all the now the particles which is heavy, which is heavier, would feel greater force, greater force, isn't it? The particles, those are heavier when the thing is spinning. The particles, those are heavier, that would feel greater force, greater outwards forces, greater centrifugal force, isn't it? And if it feels greater centrifugal force, then what would happen? It would get sedimented at the bottom. Okay. After the centrifugation is done, it would get sedimented at the bottom. Let me show you. If you cannot imagine what is happening, you'll be able to understand if you just watch this video. Let's see. So you can see that due to the centripetal acceleration, you can see that is the thing. That is the thing. Due to that acceleration, due to these forces, what is happening? The heavier red blood cells over here, they are at the bottom. They are settled down at the bottom. And the white blood cells, they are on the middle. So you can just look into this line, this white line over here. So that is the white blood cells. Okay. And there is the plasma. The lightest part is on the top. Okay. Okay. Plasma is the lightest. It is on the top position. So thus the components of bloods get separated by the principle of centrifugation. Now that is the force that is throwing it away. That is the centrifugal force. Okay, I think you got it. This video was pretty amazing, isn't it? So I think you got the centrifugation process so far. Okay, I think we can move on. Now the next process is evaporation. Now where do we use this process, evaporation? Now think about it. If you have a solution, a beaker, where you have mixed, water and sugar, which type of solution is this? So this is a homogeneous solution, mixture, I should rather say, homogeneous mixture. And we can also say that this is a true solution, isn't it? True solution. What is the preferred particle size true solution? This is near about 10 to the power minus 9 meter, isn't it? So the preferable particle size in a true solution is 10 to the power minus 9 meter. So one by one. On the first place, we just learned that how to separate out a suspension type solution. To separate out suspension, the process we use, the process we use to separate out suspension, okay? The process is we use is decantation. Sedimentation or decantation, you can say any of it. Any one of it, okay? Just give me a moment. Yeah. Sedimentation or decantation, okay? This is the process we use to separate out, yeah, to separate out the suspension type solution where the particle size is more than 10 to the power minus 6 meter. More than. There we use this decantation process. Fine. Now, if the solution is just like a colloidal solution, then which type of method do we use? We use the centrifugation, isn't it? We use centrifugation. Now, if the mixture is a true solution where the particles are not even visible, where the particle size is near about 10 to the power minus 9 meter, we can also say 1 nanometer. Then how to separate out the constituents of a true solution? So the method through which you can do it's called evaporation. Fine. So in evaporation, I think now you know it, know this process evaporation. So this is very simple. What you have to do is there are the sugar particles inside this water, isn't it? So if I just try to draw them, okay, yellow won't work, isn't it? Yellow won't work. Red would. Okay. It's already red. Now, so the sugar particles would be there, isn't it? Would be there. Now, when you would start heating it, then what would happen? As water has boiling point 100 degrees centigrade, and sugar has larger boiling point than that, then what would happen? The water would get evaporated, isn't it? And when the water would get evaporated, the thing that would be there as a residue is the salt or the sugar, whatever you take, salt or the sugar, that would be there as a residue. So when you have two components, so just try to for a moment. So when you have two components, those have a high boiling point difference. There we use this process. If one is having near about 100 degree on 100 or 200 degree centigrade boiling point, and another one is having near about 4 to 500 degree centigrade, in those processes we use, okay, we use this type of processes. So that is when the boiling point difference, when the difference in boiling point is very high. There we use this process. Okay, this like when first we just take it and try to evaporate the entire solution from there, and not the entire solution, so only the solvent from there, and the solute that is having higher boiling point, that would be left there. Okay, and in that way you can just separate out the water and the salt or the sugar, isn't it? That's a very simple process as well. Now that was about it. Now the next process is this sublimation. So this process is a little bit different. Okay, so sublimation is, like you can see, sublimation is the transition of substances from solid phase to gaseous phase without changing into liquid phase. You know about it. When the solid phase is getting changed into, directly getting changed into gaseous phase, isn't it? That was there in your like you have read about it, like solid to gas, that is called sublimation, and solid to liquid is called melting, isn't it? All these things are known to you. So the solid to gas formation is called sublimation. Now in with the help of this you can separate out two component, a mixture. So if you just think about, you have mixed salt with NH4Cl, with NH4Cl, or with naphthalene balls. You can also say that with naphthalene balls, whatever, we can just stick to NH4Cl. So when the NH4Cl and the salt, both of them are mixed together, both of them are white in color, you'd not be able to separate out, physically with your naked eyes, you'd not be able to separate them, you'd not be able to even recognize them, which one is salt and which one is NH4Cl. So what would you do? So the process that you have to do is, let me show you this. Like you need to take a funnel, okay, an inverted one, like this. Okay, now what you have to do is, you need to put your dish over here, and you need to put the entire funnel over your dish. Okay, like that, like that, to put it over that, like you can see this. If this is the funnel, okay, you need to put it like this. Okay, after by closing the upper surface of that dish, and that dish is containing, that dish over there is containing two things. One is, so the entire color would be just the same, right? So it, yeah, so it would be containing the mixture of salt and NH4Cl. Fine. So from this mixture, we are going to separate out the salt and NH4Cl. What you have to do is, you just need to heat the thing. Okay, you just need to heat this thing. Now, if you just heat this, what would happen? Well, this is nothing but a fan. Look, NH4Cl has a tendency to sublimate. Okay, so what happens is, NH4Cl is just like mothballs or naphthalene balls. Okay, so it gets sublimate. So when you just heat it, it would get directly converted from solid to gas. Got my point? So what would happen? This NH4Cl would go out like the gases. So this is the NH4Cl going out. Okay, but your work is to separate them. Okay, so if we just let this NH4Cl go, you will not be able to get this NH4Cl anymore. That would be gone. So if you want to take it as well, you want to separate them, not waste them. So if you just want that NH4Cl again, you just take that beaker, like that funnel, like the inverted funnel, like this one. So this is there to collect this NH4Cl only. So once the temperature is low, there it would get condensed, would get deposited in the solid forms, in the surface of this funnel. So the entire glass would look white because the NH4Cl is there deposited on the entire glass. Okay, that is how you can separate out this NH4Cl and this salt. So in the beaker, the salt would be there, and the entire funnel would get surrounded by this NH4Cl only, the white color solution. The white color, not solution, the solids. Okay, so that is how you can separate out these things. I think we have got all of it. So now we are just going to discuss the FAQs. You can see what are the chemical methods of separation. What are the chemical methods of separation? Okay, let's just start with this, because the method of separation we have already discussed about it, isn't it? So how can you separate sand and salt? This is a very important question, and this is frequently asked, really. Now, how to separate sand and salt? You try to tell me how to separate them, sand and salt. So if you have a beaker, think about it, containing sand particles. Okay, all of beaker also contains the salt particles as well. How would you separate them out? This is a very simple question. This simple process you need to use. Okay, very simple process. So how to separate them out? Think about it. So what would you do is you would just add some water in it, isn't it? What would happen? The salt, if you just add some water in it, what would happen? The salt would get dissolved in water, isn't it? And now after adding water in it, you just filter this entire thing. So add salt and water. Okay, sand won't be there. Sand would be there as the residue inside the beaker. And now filter it. Now filter it. What would happen? You would have a beaker containing salt and water. Containing salt and water. And the first beaker, this thing would contain only sand. Okay. Now what would you do? Now to take this sand out of this beaker, what you have to do is, tell me, what would you do to separate out the salt and water now? Now to separate out the salt and water, you'd heat it. Okay, you'd heat it. And if you heat it, then what would happen? The water would get evaporated. Got my point? So there are so many methods we are using, isn't it? So in this beaker, then we would have only the salt particles. Would have only the salt particles. Are you getting it? So there are 3 steps we are using. First, we are using water, addition of suitable solvent. So the sand would get not get dissolved in the water, but the salt would get dissolved there, right? Now, after that, what would you do? You just filter that entire thing. If you just filter the entire thing, what would happen? The entire solution would go through it. Salt and water solution would go through it as a filtrate, and the residue, there would be the sand. Sand is getting separated. Now the salt and water, from the salt and water, you need to separate salt and water. What to do? Evaporation to dryness. You just evaporate it up until and unless the entire thing becomes dry. What would happen? The entire water would be gone. Okay, it would go out, and the salt would be there in the beaker, right? So this is what how you can separate the entire thing. Okay, so I think that was it. I think you have understood all of it, and if you still have any doubts, you know what you have to do. I've already told you in the beginning of the video, what you have to do is you just have to write it on the forum. Now the last thing is there is Coca-Cola as a mixture. Okay, so if I just try to think about it, Coca-Cola is a solution, isn't it? Because all the thing there in Coca-Cola, what happens is the entire, like the solution, this is nothing but a solution, because there is water, there is carbon dioxide as well, there are sweeteners, there are sugars, there are so many other things as well. So what happens is homogeneous solution. So wherever homogeneous mixture, so wherever we see a homogeneous mixture, we can call it a solution, right? So for that reason, Coca-Cola is a solution. This was more like a question which can be discussed in the next video, but it's okay. You can see it is written over here. So all the sugar and everything over there is used. Just wait for a moment. Yeah. So Coca-Cola is a homogeneous mixture. You can see the basic ingredients of Coca-Cola is the sugar and the water and the carbon dioxide. All of these things are blended together. Okay, so that is why it is a homogeneous solution. Fine. Or you can say homogeneous mixture, and every time homogeneous mixtures are the mixtures we call solution. Okay, so that's it for today, and we have completed it. And definitely I think you have understood all of it. This was a very simple video. There was nothing special in it. I would rather say if you just have listened to all of these things with your proper attention, I think you have got all of it. Okay, and that's it for today. Thank you for being with me, and keep on learning from Ask IITians. Okay, we'll meet on the next video. Bye everyone.